All right, a different model. Here we have a slight variation. Here we're maximizing, actually negative. This needs to have a negative sign in front of it since it's a bad thing. Weeks unemployed minus effort costs. And as a matter of fact, since we've got two negative things in here, what we could do instead would be to minimize weeks unemployed plus effort costs. So it doesn't really matter which of those you choose. I guess I'll do the minimization problem. Might as well. So here we go. We have a picture of weeks unemployed as a function of job applications. So the more applications you apply to, the less likely you are to, or the fewer weeks you will be unemployed. So this might make sense. And then the effort cost is the same as it was previously. And if you add those two graphs together, you're going to get something like this, where you're trying to minimize A, and so this might be A star old meaning before the market conditions went south. So this would be this would be our objective function, a graphical depiction of our objective function. And of course we're still looking for a first order condition where the tangent is equal to 0. So let's do that. All right, here we have our marginal. Well, this is the marginal benefit. Like if this were a maximization problem, this would be the marginal benefit. So I'm going to call it the marginal benefit because increasing job applications decreases the weeks unemployed, so that's a benefit. Here's our marginal cost. Increasing applications obviously increases effort costs. So we've found a value of A star, optimal applications, I'm calling it A star old, that optimizes our objective function. Now that everything's in equilibrium, we're going to offset equilibrium by changing our exogenous variable to see how the graphs respond. Now, the trick here is that we don't actually know which of these two things is going to happen. Is it sort of, is it that the difference between a good job market, the black line, and a bad job market, the green line, sort of gets bigger as you apply to more jobs, or does it get smaller as you apply to more jobs compared to before? And you can actually model each situation. You can make an argument for each situation. Quick mistake here. So these are both positive, so this should be positive. Now, if it seems weird that a positive plus a positive equals 0, just remember that this derivative is negative. So that's how we explain that. All right, I'm going to go with my own intuition about this graph, and my own intuition is that the difference is going to be greater for a greater number of job applications. Because I think the people who get a job pretty early with their job applications are probably people with connections or people who have kind of unfair advantages anyway. It's the people who need to apply to a lot of jobs generally who are going to have a worse situation when there's a downturn like there is with COVID. So, my intuition is that this has happened, in which case, what has happened to the magnitude of this slope? And we know this whole thing's negative, so this is negative. We just want to ask the question, is the magnitude of that negative thing going up or down? And the way I've drawn it, it goes down. So if we compare what happened to the slope, I believe the magnitude has gotten flatter, and this is 2020, and this is 2019. So this is a good job market, this is a bad job market, and we have a flatter slope in the bad job market. So that means that a drop in the market conditions led to a decrease in the magnitude of this factor. And that means our whole thing is less than 0. Since this is our negative thing, this whole thing is less than 0. We're not in equilibrium because we know at equilibrium our first order condition is equal to 0. So the next question is, how do we counterbalance that? And there's two ways to counterbalance that. One is just go in the opposite direction. We had a decrease in the magnitude here, so we could have an increase in the magnitude. The other is for our cost, and this is negative, this is positive. We could go in the same direction. So decrease here and decrease here so that these counterbalance out. And then our final thing, of course, is how do we change our choice variable to achieve what we need to counterbalance our first order condition? And we can do that. What we need is an increase in the magnitude of this slope, so we need it to become steeper, and we can test increasing A, or decreasing A, and we see that actually decreasing A is going to achieve that. Or we could decrease this slope, and we can find that decreasing this slope also is associated with a decrease in A. Well, we've just gone through this entire intuition, and we ended up at the same result. We ended up with a positive elasticity. Let me write out the result. The result of these comparative statics were a decrease in M led to a decrease in A. And so if you still believe that this elasticity is going to be the truth, or if it matches some of the data you see, you're going to have to adjust the story to figure out how can we explain that. And of course, one way of doing that is by saying, okay, maybe I was wrong about the way that I drew this shape. Maybe, in fact, instead of it going like this, it goes the other way, the way the purple one went. So let me draw that, and let's see if we can figure out the story. Alright, so now I'm looking at this graph. This graph was not initially my intuition about the way these variables would work, but can I tell a story that matches this graph? Yeah, I could actually. I could say, well, jobs are so few and far in between that the first few jobs you apply to, it's unlikely they'll follow through. But as you apply to more and more, just flooding the market with your application, there's still jobs out there to be had. So maybe if you flood the market with your applications, maybe you're not as disadvantaged as you were. I mean, you're more disadvantaged than before the downturn, but maybe it doesn't make as much of a difference if you're applying to 100 or 500 jobs. So of course, if this is the shape of the graph, all of our comparative statics change. So now finally we've found a result where a decrease in the job market leads to an increase in job applications that would have to be associated with this level of application success before and after the downturn. And in which case, we've come up with a situation that more closely aligns with the underlying situation if our data support the first hypothesis. So that's just sort of walking you through some comparative statics and how we might use it to think about what are the underlying forces behind any data correlation that we're observing.